Welcome to Advanced Foundation Maths lecture series. In today's lecture, we will cover chapter 6, which is binomial theorem. So let's get into it. A binomial expression is an expression having two terms with a positive or negative sign in between. Binomial theorem is a formula by which any binomial expression to a positive power can be expanded. So let's understand this. X plus y the whole square, we know this is equals to x square plus 2xy plus y square. Similarly, we know x plus y whole cube is equals to x cube plus 3x square y plus 3x y square plus y cube. Now, if you notice that in these expansions of these binomial expressions, the power of x is decreasing if you go term by term, and power of y is increasing. For example, here we have x cube, here we have x square, here we have x to the power 1, and here we have x to the power 0. Now here we have y to the power 0, y to the power 1, y to the power 2, and y to the power 3. Now, another thing, if you notice, that we can write this as 2c0 times x square plus 2c1 times xy plus 2c2 times y square, where we know 2c0 is 1, so therefore this would be equals to this, and 2c1 is 2, 2c2 is 1, so therefore this formula works. Now similarly, this can be written as, so x cube, now this is x square y, this is xy square, and this is y cube. Now the coefficient of this is 1, so which is 3c0. This is 3c1, which is 3. This is 3c2, which is still 3. This is 3c2, which is again 3. And this is 3c3. Now, in general, binomial theorem states that x plus y to the power n would be equals to. So this would start with the maximum power of x, which is x to the power n, plus now the power of x will decrease, so this would be x to the power n minus 1. Now here we have y to the power 0, for example, so this would be y to the power 1. Next would be x to the power n minus 2, and this would be y to the power 1, so this is y to the power 2, and plus next would be x to the power n minus 3 y cube plus dot dot dot. Now the last term would be y to the power n. So let's write the coefficient. So the coefficient here would be nc0, this would be nc1, this would be nc2, this would be 3, and this would be ncn. So this is the expansion of x plus y to the whole power n, and we must memorize this. Also note that this is the first term of binomial expansion, this is the second term, this is the third term, this is the fourth term, and if you keep going on, this would be n plus 1th term. So in general, if we want to write the t r plus 1th term of this, so that would be equals to, so if you realize that if this is 2, this is 1, this is 3, this is 2, so therefore this would be x and y. So if this is r plus 1, it would be y to the power r. Next thing, if you note, is if this is 2, this is n minus 2. If this is 3, this is n minus 3. So this would be n minus r. So essentially, if keep it in mind that this is 2, so this is also 2, and this is also 2. So therefore, this would be ncr, meaning this term, meaning the number here and here and here, all these three are same. So this is the general term of the binomial expansion. Now, in general, in the expansion of x plus y to the whole power n, the number of terms is n plus 1. as we just saw. Next thing, if you note in the expansion we just wrote, that sum of powers of x and y in each term is constant, and that's equals to n. Third thing, which is important, we must notice that the general term in the expansion is r plus 1th term, which is equals to ncr x to the power n minus r and y to the power r. So the binomial coefficient of this term is ncr, meaning only this part. Also, pth term from the end is n minus p plus 2th term from the beginning. Next, let's do a question. Write the 2r plus 4th term in the expansion of a plus bx the whole power 18. In this bracket, think of this as the x part and this as the y part. And we are doing the expansion of x plus y to the whole power 18. So 2r plus 4th term would be t 2r plus 4. Now we need to write this in this form. So meaning t of something plus 1. So we can see that this would be 2r plus 3. So this would be equals to 18, which is n, c r, which is 2r plus 3, and then this to the power, which is a to the power n minus r, multiplied by y to the power, so y in this case is bx, to the power r, which is this, so 2r plus 3. So this is the 2r plus 4th term. Now similarly, r 2th term, r minus 2th term would be equals to t of something plus 1. Now this would be r minus 3, would be equals to 18c r minus 3 a to the power n minus r minus 3 y to the power, which is bx to the power r minus 3. So these are the terms asked in the question. Additionally, it's given if their binomial coefficients are equal. So these are the binomial coefficients. So it's given that their binomial coefficients are equal. So if you recall, we have seen this formula that if ncx equals to ncy, then we have two possibilities, either x equals to y or x plus y equals n. So therefore, we'll apply the same here. So we will get either 2r plus 3 equals to r minus 3, which would imply r equals to minus 6, which is wrong because r is the rth term, which cannot be negative. So second option is that 2r plus 3 plus r minus 3 equals to 18. So this would give us 3r equals to 18 or r equals to 6, meaning when r equals to 6, their binomial coefficients are equal. This should not be x, this should be r. So we found out r as 6, for which the binomial coefficient of these two expansions become equal. Now let's look at another question. In the expansion of x square minus 2 by x whole to the power 12, we have to find couple of things. So let's just write down what we just saw. X plus y the whole power n. The general term of this is t r plus 1, which is equals to ncr x to the power n minus r y to the power r. Now let's write down what's given to us. So x square minus 2 by x. So this minus 2 by x, you can think of this as x plus minus 2 by x whole to the power 12. So therefore you'd be able to identify that this is the capital X here and this is the capital Y. So let's see the answers one by one. So first is the number of terms. So here if you identify n equals to 12. So therefore number of terms we know is n plus 1. So therefore this would be equals to 13. So there would be 13 terms in the expansion of this. Second is general term. So we know that general term is r plus 1th term. So that would be equals to tr plus 1 or r plus 1th term is equals to ncr x, which in this case is x square to the whole power 12 minus r multiplied by minus 2 by x, which is y whole to the power r. So this is the general term. Now next is find the 10th term. So 10th term would be equals to T10. Now that we can write as T9 plus 1. This is done so that we can write this in this form. So this would be equals to 12c, now r is 9 here, so 12c9 x square whole to the power 12 minus 9 minus 2 by x whole to the power 9. So this would be equals to 12c9 x to the power, this would be 3, so 3 multiplied by 2 will give us 6. So this would be 6 and this would be minus 2 whole to the power 9. So this would be minus multiplied by 2 to the power 9 divided by x to the power 9. So this would be equals to minus 12c9 2 to the power 9 divided by, now this will cancel out this with x cube divided by x cube. So this would be the 10th term in the expansion of this. Also, if you simplify this, we will get minus 12 c9 2 to the power 9 and x to the power minus 3. So this is the 10th term. Now if you notice, the coefficient of x in the 10th term is minus 3. Now next question is find the term containing x to the power 18. Now this is a reverse question where they are not asking you to find the term. Instead, they have given that the term contains x to the power 18. Now what's the term? So in such scenarios, we will write the general term and we will try and combine the power of x. So for the fourth one, we will write the general term. Now we will combine x. So this would become 12cr minus 2 to the power r and x to the power 24 minus 2r, and this will come in the numerator with a minus sign. So therefore the power of x would be 24 minus 3r. So now they are asking the term which contains x to the power 18. So essentially the exponent of x is equals to must be 18. So that implies 24 minus 3r equals to 18. So that would give us r equals to 2. So therefore the term containing x to the power 18 is t2 plus 1, which is t3, that is the third term. So essentially the third term would contain x to the power 18. Now if we want to find out, so it would be 12c2 x square whole to the power 12 minus 2 and minus 2 by r whole to the power 2. So this would give us 12c2 x to the power, this would be 10, so this would be 20, and this would be 4 divided by r square. So this would be 12c2 into 4 multiplied by, now x to the power 20 divided by x square would give us 18. So as we can see that third term is actually the one which contains x to the power 18. So our answer is correct. So for the last part, meaning term independent of x, we will substitute this exponent of x as 0 so that x vanishes in that term. So this will give us r equals to 8. So that means the term is t8 plus 1 or tr plus 1. So meaning it is the ninth term. We can also find out the value. So this would be equals to 12c8 x square to the whole power 12 minus 8 minus 2 by x to the whole power 8. So this would give us 12c8 x to the power, this would be 4 and this would become 8, and this would be 2 to the power 8 divided by x to the power 8, because minus 2 whole to the power 8 would be 2 to the power 8. Minus will vanish. So this will get cancelled. So finally we will get 12c8 2 to the power 8. So this is the term independent of x, which is the ninth term. We just saw the expansion of x plus y to the whole power n. So this equals to nc0 x to the power n plus nc1 x to the power n minus 1 into y plus nc2 x to the power n minus 2 into y square plus nc3 x to the power n minus 3 y cube plus dot dot dot. Now, if this is the expansion of x plus y whole to the power n, then the expansion of x minus y whole to the power n would be nc0 x to the power n. Now the second term would be negative. So this would be minus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square, and then fourth term would be negative, so it would be minus nc3 x to the power n minus 3 y cube plus dot dot dot. Now if we add these two, we will get x plus y whole to the power n plus x minus y whole to the power n would be equals to, so if we add the second term, the fourth term, and so on, these will get cancelled. So this will get cancelled with this will get cancelled with this, so we'll be left with nc0 x to the power n plus nc0 x to the power n. So it will become twice of nc0 x to the power n plus nc2 x to the power n minus 2 y square plus dot dot dot. Similarly, if we subtract x minus y whole to the power n from this, meaning x plus y whole to the power n minus x minus y whole to the power n. So this will become, so here, so in this case, the first term will get cancelled, the third term will get cancelled, and so on. The second term will become double because this minus of this. So this will become twice of nc1 x to the power n minus 1 y plus nc3 x to the power n minus 3 y cube plus dot dot dot. So let's do a question on this. Simplify root 2 plus 1 whole to the power 4 plus root 2 minus 1 whole to the power 4. So let's say we need to find the value of this. So this would be equals to twice of, so this would be the first case. So twice of 4c0 root 2 to the power 4 plus 4c2 root 2 to the power 2 multiplied by 1 to the power 2 plus 4c4 root 2 to the power 0 and 1 to the power 4. So this would give us 2. This would become 4 plus 4c2 would be 6 multiplied by 2 plus 1. So this would become 12 plus 4, which is 16, and this would be 17. So 2 into 17 would be equals to 34. Now next is middle term in the expansion of x plus y whole to the power n. So So depending upon whether n is even and n is odd, we have two different cases. So let's take the first case when n is even. So if n is even, the number of terms would be equals to n plus 1, and hence it would become odd. So for example, when n is equals to 4, the number of terms would be 5. So t1 plus t2 plus t3 plus t4 plus t5. So the middle term is clearly t3. So therefore it will have only one middle term, which would be t n by 2 plus 1. Now next case is when n is odd. So let's take an example. When n is odd, let's say n equals to 5. So in such case, the number of terms would be 6, which is even. So number of terms is n plus 1, which would be even in this case. So it would be t1, t2, t3, t4, t5 and t6. So there would be two middle terms, which is t3 and t4 in this case. So the middle terms in general would be t n plus 1 by 2 and t n plus 1 by 2 plus 1. Note that these two terms are consecutive, and when you substitute n as 5, we get this as 3 and this as 3 plus 1, which is 4. Students are advised to memorize these different cases. So let's do a question. Find the middle term in the expansion of a by x plus bx whole to the power 12. So here n is equals to 12, which is even. So therefore the number of terms would be equals to 12 plus 1 or n plus 1, which would become 13, which is odd. So clearly there would be only one middle term. So that would be t n by 2 plus 1. So that would be t 12 by 2 plus 1 or t 6 plus 1, meaning the seventh term. Now let's find that middle term. So t7 or the seventh term would be equals to t6 plus 1 would be equals to 12c6 a by x whole to the power 12 minus 6 bx whole to the power 6. So this would be equals to 12c6 a to the power a by x whole to the power 6 into b to the power 6 x to the power 6. So this would be 12c6 a to the power 6 divided by x to the power 6 multiplied by b to the power 6 x. So x to the power 6 will get cancelled, and this would be 12c6 a b whole to the power 6. So this would be the middle term of this expansion. Students are advised to practice more questions from the booklet. Thank you.